I'd like to welcome everybody. My name is Larry Arthur. I'm the president of the Indiana ACI, and I want to thank everybody for joining us today. Great opportunity to listen to Mike Collins talk about Portland Limestone Cement. We had the opportunity a month or so ago to hear him talk about all the characteristics of cement. So this was a subject that it seemed like everybody was interested in hearing about. So I reached back out to him, asked him to come back around and talk about this. So we'll be recording this. It'll be online at our YouTube channel for further viewing. I want to, after this, if Mike's okay with it, I want to share his contact with everybody because he is a wealth of knowledge when it comes to cement. He will have several of his technical people on here from Lehigh. So there will be plenty of people here to answer questions. So fire away with whatever questions at the end you've got. Please keep your microphones muted throughout the presentation. At the end, we will open them up and allow people to ask questions. So I'm going to turn it over to Mike Collins. Mike, thank you for joining us. And as always, it's a pleasure. And the show is yours, sir.
Okay, thanks, Larry. Appreciate the opportunity. As I mentioned in December when we had this chance to get together, it's a different season that we're living through. With things like COVID that affect our face-to-face meetings, and organizations like Indiana ACI have done a great job of really pivoting when that situation presented the obstacle, and they pivoted to things like these webinars that I think have really opened up a whole new world of opportunities to us. I know I've learned a ton over the last year with different webinar opportunities. So I appreciate Larry continuing to make these available and giving me a chance to come back and share with you folks again. If you remember from the talk that I gave in December, one of the things that I like to do is talk about leadership stuff. So we're going to hit that just a bit as we get kind of going here today. But this is a packed agenda. There's a ton of stuff we're going to cover. I'm willing to sit here and answer questions as long as you guys have questions. I've got some of our technical service team from North America here on this call as well. So if I don't know, I'll tell you I don't know, but I would venture to say someone on this call from Lehigh has an answer for you. So we're just going to look at some things today, really to kind of get into the roots of why PLC is even an option. We're going to get into the history of Portland Limestone Cement. We're going to talk about how it works, what it can mean for you as a producer or contractor. Then I want to look at some data, some projects where PLC has been used. Make sure that you leave this time with some resources, and then specifically give help for specifiers on some ways that you might be able to incorporate PLC into what you're doing. And then just close out our time together with a customer testimony. And so our first slide here talks about, this is kind of where we're going to approach our leadership angle. And so Simon Sinek wrote a fantastic book called Start With Why. And these three circles here on the right of your screen, that kind of gets to the gist of everything that he's trying to get at in that book. And so there's the what of what you do, there's the how of what you do, and there's the why of what you do. And for us, it's so important to understand the why. The why drives you. The why provides your purpose. The why gives reason to why you get up out of bed in the morning in some cases. And so for us, as we consider Portland Limestone Cement, the why is very important. Why are we even having this talk? Why is Portland Limestone Cement even an option? And so that's a great question. And it's one that I want to dive into just a bit to kind of set the groundwork for us going forward. So it really gets back to the world that we live in, right? So I would venture to say that it's hard to go through a day where we don't hear someone say carbon footprint or carbon reduction or carbon neutrality. And so as those three things become more and more prevalent in the world we live in, we have to start addressing that. We have to address it individually as just people that live in this world, but we also have to address those kind of things from a business standpoint, and it's going to become more and more prevalent as we work through our days. So I did a quick Google search this week and just typed in carbon footprint. I got 5,050,000 hits for carbon footprint in 0.42 seconds on Google. Kind of blew me away. And just a couple of examples from that Google search. For instance, the Wall Street Journal, airlines push to reduce carbon footprint with greener fuels. The BBC News, calculate the environmental footprint of your food, something that I'm really not interested in doing today. And really, in the United States, we've got a new administration that promises in their first 100 days to jumpstart the whole climate change agenda. So those things, carbon footprint, carbon neutrality, carbon reduction, they are a part of the world that we live in. And so for us as a company, and when I'm saying us, I'm talking about Lehigh Cement, but I'm also saying as an industry, a way for us to really begin to get our hands around carbon reduction is to let that be something that we use Portland Limestone Cement for. So Lehigh, I work for Lehigh, been with Lehigh almost 33 years. Lehigh is a part of the Heidelberg Cement Group, and Heidelberg is very serious about this. So from a 1990 baseline, they have established that by initially it was the year 2030 that we would see a 30% reduction corporately in our CO2 output. That has now been ramped up, or I would say actually cut down to 2025. And now the ultimate goal is by 2050 that we would be a carbon neutral company, realizing the vision of carbon neutral concrete by at the latest by 2050. How do we do that? There's a lot of different ways. There's some fantastic research going on in the world. What I want to talk to you today is a very simple way that you can begin to do this as individual producers, something that we're looking at as cement producers, and that's with Portland Limestone Cement. And so let's talk about the history of PLC, because what I want you to really understand, this is not a new product. This is something that has been around for quite some time. Some forms of PLC have been used in Europe for more than 40 years. It's very common over there, and you will see cement factors with limestone contents all the way up to about 35%. PLC has been used increasingly in Canada since its adoption in the CSA A3000 specification in 2008, where that specification allows quantities up to 15% with very similar provisions to those in ASTM C595. And PLC has been used in the United States in accordance with ASTM C1157 since 2005, and now PLC is being specified as ASTM C595 cement type 1L. And here on the right, you can see this is the map of the state DOT acceptance of Portland Limestone Cement. If I was to throw that map up there in about 2012, it had a lot of yellow on it. And more now you start to see states embrace this product because the flat out truth is it works. And we're going to talk about that a bit over the next several minutes. So as we talk about how it works, let's get into the mechanisms of PLC a bit. And really to understand how PLC works, we need to look at how it's made. And so as I briefly mentioned, type 1L is a blended cement, and it's covered under ASTM C595 and AASHTO M240. So under those specifications, it's allowed 5 to 15% limestone by mass. And so this next point is something that I want to make sure everyone understands, because this is the question that I routinely get. Portland Limestone Cement, our C595 cement, is very typically made from the very same clinker as the C150 cement from that same cement plant. The only difference is that PLC just has about 6% roughly more limestone. And a key is because it is a blended produced cement, it is designed for equivalent performance. And we're going to talk about that a bit. So this schematic here shows what a modern cement plant looks like. And then the blue bubble, that's really the only place that you see any difference from the production process on a C150 cement versus C595. So in that blue bubble, we would take that same clinker that would go into the C150 cement. That same clinker is ground with an extra addition of about 5 to 10% extra limestone, and it's replaced in the finish mill with the clinker at 1-to-1 ratio. Very important to understand that this PLC is ground finer, and that's necessary for equivalent performance. And one of the things we talked about in the December session was a C595 cement, because it is blended and interground at the actual cement production facility. It's optimized for set control. The sulfate is optimized. And that's, again, remember where, I don't know if you remember, we talked in December about we have to look at the concrete as a system. and the cement is a part of that. And so the sulfate that the cement brings to the system is really tasked with controlling a lot of the reactions that take place once hydration begins. And so we are able to optimize the sulfate content on our end as a cement producer when we do make that 595 cement. So kind of this slide I threw in at the December presentation because we just kind of skimmed over PLC at the time, but I want to dive into it a little deeper. I've added some more to it since December. The whole key really, I think, to the PLC performance is understanding that the limestone extends and occupies the finest part of a cement's particle size distribution. And we're concrete guys for the most part. We're not always cement guys. So when I start thinking about things like particle size distribution, to me, I look at aggregate gradation. And if I have a gap in my aggregate gradation, I can often blend in a third aggregate, maybe a pea gravel, and that's going to do things like increase workability or increase strength. It could reduce my water content, whatever it may be in that particular aggregate situation. That's almost what we're doing here. We're taking the cement particle size distribution, which would be the black line, and we're blending in the fine limestone powder. And so what that does, again, is kind of fill in some of those gaps in the actual particle size distribution of the cement. That actually drives a lot of the good stuff that comes out of the performance issues that we see with Portland Limestone Cement. And so some things that start to happen is we see an enhanced particle size distribution. So in other words, that cement typically would make a denser concrete. That leads to reduced porosity. And one of the things I think that limestone cement has battled over the years is that people think the limestone is inert, that it's just kind of a filler material, and that's actually not correct. That there are some hydration reactions that take place. So the tricalcium, tricalcium aluminate in the clinker actually reacts with the underground limestone and produces a hydration product called calcium monocarboaluminate. That's kind of a big mouthful, but the point there is that this is a hydration product. So if you remember from our December talk, we talked about calcium silicate hydrate, CSH. That's the stuff that really we want to maximize when cement and water start to hydrate. That's the strength gaining mineral. This is also a hydration product, and this actually begins to help do some really cool things like, again, reduce the porosity in the mix and does give that little bit of early strength boost that you typically see with the Portland Limestone Cement. The other good thing that happens is because that limestone is so intimately ground and mixed with the material, the cement clinker, that you have nucleation sites. And what that means is that there's some sites where precipitation, these hydration products can kind of latch onto and start to grow a little quicker. And so it helps overall matrix structure within the concrete. Just all really a function, I think, of the particle size distribution and how the limestone being ground with that clinker tends to enhance that. So some advantages of PLC. So what does PLC do for me? Well, the primary advantage is that it allows for a reduction in CO2, typically something up to 10%. And so let's start to hang some numbers on that. In the United States, from the years 2012 to 2018, there were 4 million metric tons of PLC used in concrete. What does that mean for us in terms of CO2 reduction? So that was 325,600 metric tons of CO2 savings in that same time period. So what does that mean? Well, that's equivalent to 70,344 passenger vehicles driven for a year. That's the equivalent CO2 output. So that's to be the same if we took 70,300 cars off the road. We've saved that much CO2. That's enough CO2 that the energy used could have powered 37,500 homes for 1 year. And that's also the equivalent CO2 that's sequestered by 425,000 acres of U.S. forest for 1 year. And so I throw all those numbers at you because I think we need to hang some everyday data on this, where this begins to show us why this is important. 4 million metric tons of PLC, that's across a 6-year period. We're way past that now. The whole PLC train has left the station, really, and you can start to see consumption pick up across the United States. And as it does, the CO2 savings is continuing to escalate as well. That's a good thing. That's what we want to see. And again, that's the primary advantage when we use Portland Limestone Cement. But as a producer, there's some other good things that happen. So if you were to take PLC and going to use that at your operation, you're going to find it's a very simple, straightforward switch in your operation, essentially a plug and play. What I mean by that is you pull out your ordinary Portland cement powder out of your mix, replace that 1-to-1 with PLC straight up. And that's essentially that's what you have to do. At that point, you've made the switch and you are in a position where you're going to see a carbon reduction in your concrete. So really what it does, PLC provides you an opportunity to go green and increase your sustainability without spending money on capital investments for specialized systems at your concrete plant. That's huge. That's enormous. What the environmental sustainability increase that you see with the use of PLC comes from doing something you're already doing. You have a cement at your plant that you put into your concrete. All that is required at this point is to change powders. And you at that point are starting to see these kinds of metric ton CO2 savings that we demonstrated on the last slide. Just want to throw this in here just briefly. I don't want to get into this because we could have a whole separate talk on EPDs. If you've not heard of EPDs, I would suggest that you will, probably sooner rather than later. So let's define that. An EPD is a transparent, verified report used to communicate the environmental impacts such as resource use or energy or emissions associated with the manufacture or production of construction materials. So on your right, what you see is that environmental product declaration, and people liken this to like on the side of your Coke can, there's a nutrition label. Essentially, that's what it is. And so what I would say to you is that what I would suggest is that the main area that we're looking at here is on the far left. That is the type 1L on the global warming potential at 679 kilograms of CO2. And so beside that is the type 1 at 746 and the type 3 at 767. Again, using that type 1L cement allows us a reduction in global warming potential. And that is something that is going to become more and more significant, not only just environmentally in everyday sustainability, but also in terms of our business operations. I can tell you that on the Pacific Northwest right now, there are places where if you make a submittal and you do not include an EPD with that submittal, your submittal will be rejected. So this is something that as this comes across the country and begins to affect our particular area, we're going to become more and more familiar with. So what are the benefits of these EPDs? They provide verifiable and transparent information on life cycle environmental impact data for materials or products. And I think the whole key word in that is transparent information. People are just being honest about things, and we've got to be honest about how things are made, the ingredients in those things, whether it's the cement or the concrete or whatever it might be, because people are starting to do meaningful evaluations of life cycle assessments, things like that, where we have to know what goes into that product so we can determine the life cycle of that product and its eventual benefit in that area. So again, we're identifying areas for environmental performance improvement and encouraging industry efficiency. Okay, so I've got a buddy on the call, and his name is Scott Kelly. Scott Kelly is the Lehigh Technical Services Manager for our South region, and he did a survey recently. So in Scott's area, they have been selling and using Portland Limestone Cement for about 10 years now. So he's got some customers that have some experience with this product, and so he just asked them some questions, and I captured a few of those for us to discuss today. The first one is concrete cylinder strength performance. Is it better, worse, equal, or not sure? And so you can see about 2/3 of that group says that it's equal. A quarter says it's better, and the other folks aren't sure. So they may be in a different kind of environment where they're not looking at cylinder strengths. Concrete durability performance, again, the vast majority, 75% is equal, with a 25% not sure. Admixture compatibility, normal dosages for the vast majority, and just a hair there on abnormal dosages. And I would even go as far as to say, my guess would be that might be air entrainment, and we'll talk about that in just a bit. But typically, because of the fineness, there is a slight adjustment needed upwards in air content or in air admixture, iron training admixture, and that is typically once you dial that in, it kind of locks in and it's not an issue. It's just an initial adjustment. Marketability of being a more environmentally responsible product or greener. Is that something that is helpful? And half of those people said that yes, it is, makes them a better company. And again, about a third of those folks said it's at least equal. And lastly, does the lower carbon emissions aspect of EcoCemPLC, which that's Lehigh's trade name for our Portland Limestone Cement, have significance to your company? And again, 2/3 say yes, that it does have significance to your company. And again, these are folks that have used this product for over 10 years now, and they're starting to see not only the performance benefits, but the benefits in terms of the green aspect and marketability as they enhance their sustainability. So I kind of flew through all that because I'm a numbers guy, and I want to kind of get into some nuts and bolts about PLC, because all that sounds great. I think we'd all say we want to be interested in the environment. We want to do things that leave our world a better place for our children and so on. All that sounds great. But at the end of the day, does Portland Limestone Cement work in concrete? So let's take a look at that. So this is a slide that comes from a paper that Mike Thomas and Doug Hooten did in 2010. And what this shows is that with different percentages of limestone addition, you see similar workability and similar water demand. And there's another slide that's very similar to that. And it has this demonstrates that there's similar strength development. And I just got to stop. I got to stop at this point, because I have given this talk tons of times. You guys may have sat in some PLC talks and you see these same slides over and over. These strength slides, people run these out all the time to all kinds of different seminars, webinars, presentations. And I just kind of had the thought, what if we transition from industry data to our data? You know, I mean, how would our data match up to what we've learned from the industry? And when I say our data, I have to be honest and say I'm talking about Lehigh data, because we have a fantastic concrete laboratory in Mitchell, Indiana. And so we just said, we don't want to rely on industry information when I go and talk about this kind of stuff. Let's put our own meat on these bones. And so I'm going to share with you some real life numbers from some cements that we have made in the Indiana market and even in Mason City, Iowa. Okay, so this is an actual test report from EcoCemPLC ground at our Logansport, Indiana plant. And so when I throw that up there, I know that's hugely overwhelming. There's a ton of numbers on there. There's all kinds of information. We're going to break this down. I just want you to see how much information there was that we squeezed out of a trial guide that was done last year at our Logansport plant. And we're going to break all this down and look at all this a little closer. But the key is we have looked at this 7 ways from Sunday. And because we have really done our due diligence, I can tell you that when you use a PLC, you are going to see like for like performance or better in almost every measurable category. That's been the story that we've seen. So let's dive in and take a look at this. So if we look at strength data, and again, this is kind of busy. So what I want to do is just kind of hide some of this. So on the very far left, this is our Logansport type 1 sample from July, just our regular sample that we get each month out of that plant. And then we did our PLC trial grind in July as well. And so we put those two powders in the same mix design, same aggregates, same chemicals. We used a mid-range water reducer, 3 ounce per 100 weight dose. And this is what we got. And then we said, okay, that's really pretty close. That's kind of that like for like that we're looking at. So let's verify it. So we did a second trial grind in August, and that's on the very far right. And when you look at that strength data, again, right in line with where our type 1 is, and I would even say a little better in some categories, especially 28 and 56 days. And that if you look at the 1-day break on the PLC in August, it's the highest of the three. So again, like for like performance or better. So I know that there are some of you guys that rarely would use just an OPC mix. So what happens when we look at fly ash? And so we took a fly ash that would be common in the northern part of the state, and we mixed that with the Logansport Type 1, and we also mixed it with the Logansport PLC ground in July. And again, like for like or better, very equivalent strength performance. Also did a mix with slag and those same two cements. And again, the story is the same, a little bit better at 1 day and pretty equivalent as we go up in 7, 28, and 56 days. So from a strength perspective, comparing similar mixes, what you're seeing is that the limestone cement performs equivalently to the C150 type 1 cement. That wasn't a surprise to us initially because, like I said, we'd looked at this industry data, but what was the needed feature there was now we had confirmation. So what about set time? Because all of us are interested in set time, so let's break those down like we did on our earlier chart. So this is the very far left is the Logansport Type 1 from July. The Logansport PLC set just a hair longer, not very long, about 10 minutes longer. And then the August sample actually set equivalently to the July sample. So again, very similar performance and set time. When we looked at the fly ash, dead on. And this is doing C403 initial set with the penetrometer in our lab at Mitchell. And the slag mixes, again, almost dead on. So really, when we compare set time from between equivalent SCMs or equivalent mixes, we're seeing equivalent performance. So let's look at some of the other things we did. So to measure air performance, one of the things we do is there's a test called C185. So if you see a mill test, we talked about this in December. If you see a mill test, what that data that you're getting on that air content, that's not concrete air. That's not entrained air from a concrete. That is entrapped air that's measured in a cup of mortar, a 400 milliliter brass cup. And so what we've been doing for years in our lab is that we take that cup and we can repeat that mix and just add a very minute dose of air entraining admixture. And then we just look and see what is the difference. Does it generate air? Does it generate air predictably? Things like that. Also, by the way, just a great test to use for fly ash. I think personally better than the foam index test, but that's another talk as well. And so what we saw, mix 1 was the July Type 1, mix 2 was the July PLC, and with no air entraining admixture, pretty much equivalent 5.2 or 516 to 524. We did see about 1% less with the air entraining admixture, and again, that's something that we've seen a few different times in the field, not unsuspected or unsurprising whenever you consider the fact that that PLC is ground finer, and typically that just requires a very small adjustment in air entrainment once you make that, and then it kind of locks in and is steady and you don't have to worry about it anymore. Something that has been significant, and again makes sense if we stop and think about it, when we run the C232 bleed rate test, we're looking at a bleed percentage on a given mix. The Logansport Type 1 bleeds 9.42%. The PLC mix, again, because it's ground finer, has less bleed, about 3%, 6.38%. This is something that we have found to be beneficial in a couple of different applications. And it's something that we've seen repeated from plant to plant to plant as we've looked at our different production cements. Resistivity testing, we have a ResiPod unit at our lab, fairly close, a little more dense in the PLC mix as we would expect, again, with that increase in fines content. Something that is one of the biggest tests that we run in our lab is a C157 shrinkage test. Almost identical, 0.029, 0.030. So again, the shrinkage is a non-issue and very equivalent from mix to mix, regardless of powder in that situation. So we didn't stop there. So our lab is pretty cool. So we have a room in our lab that we can set the temperature from about 40 degrees all the way up to 100. So it allows us to kind of replicate outdoor conditions. And so we said, hey, how does this cement perform in cold weather? And so we set the room down at 45 degrees and went in and did some mixes, just kind of looking at what would be kind of an everyday, maybe interior slab mix. And just ran the time set at cold temperatures. So essentially what we found is that the PLC from Logansport sat 2 minutes quicker than the equivalent type 1. With the addition of a non-chloride accelerator, it sat almost an hour quicker, 53 minutes. And then from the plain Portland limestone cement to the accelerated limestone cement, there was 218 minutes difference. So all of this fits with what the industry would tell you in terms of time is set. It was good to see that temperature didn't have an effect on that, because we saw very equivalent time of sets with untreated samples, untreated concrete back in our room temperature tests. And again, now we can confirm that at 45 degrees, we're seeing almost exactly the same, even a little quicker set with the limestone cement. So again, the data that we wanted to see is what we saw. I know there's, to me, I think one of the best uses for PLC is in a paving mix. I just think that extra fine content from that limestone really makes that something that works fantastic through a slip form paver. And so we wanted to see how would this perform in kind of an everyday paving mix. So we did 440 pounds of cement with 110 pounds of F-ash, used air entrainer and a water reducer. And so here's the plastic data from that testing. Had 0.41 water cement ratio in both mixes, got 2 1/4 inches of slump. Air was 7.3%. And so as we go down into the strength data, especially focusing in from the paving standpoint on flexural strength, we had 631 PSI of flexural strength in 3 days, 668 in 7 days, and 723 PSI flexural strength in 28 days. So again, just really outstanding performance, and did as good or better than the Mitchell Type 1, which has been used with a lot of success in paving up to date. Another question that we're asked is, what about sulfate resistance? So our very first trial grind at our speed plant was in April of 2019. And so we sent some of that material off that year for C1012 testing. As you know, that can run out a bit. So we're carrying that all the way out for 18 months. So some early data that has come back is that the PLC control with no SCM has met S1 sulfate exposure rating. And that shouldn't surprise us, right? Because we said the clinker is the same. So the clinker chemistry is the same, and speed is a type 1-2, typically without an SCM. Speed type 1-2 cement meets S1 sulfate exposure rating on its own. And so we see that carry over to the PLC using that same clinker. So the PLC control reaches S1 sulfate exposure rating just fine. When that speed PLC is used with a 15% F-ash, easily met S2 sulfate exposure rating. And then when we put that in a mix with 30% slag, it really is starting to flatten out, and it's already met S2 sulfate exposure, and I would expect that to easily reach S3 as well. So we're going to carry that on out into the 18-month mark, but I can't expect it to do anything crazy and not make S3 at that point. You know, from some early testing, what we're seeing there again is that the limestone cement has no adverse reactions to sulfate. It performs very typically as compared to the C150 cement at the plant where it was produced. And so we went ahead and we've sent all 4 PLCs from the Midwest region out for 1012 testing as well. Color. So you are adding some more limestone, right? And limestone's typically much wider than clinker is. And so under glass, if you were to look at the 2 powders, the PLC would be lighter. And if you've ever been to our concrete school, for instance, we show you a type 1 cement under glass versus a type 3. From the same plant, the type 3 will always be lighter. That's because it has more gypsum in it. So it shouldn't shock us then that if we put a type 1-2 beside a type 1L from the same plant under glass, that type 1L is going to be lighter. And again, that's because it has more of the whiter limestone included in it. But we don't, powder is not the end game for us. It's where does this end in concrete? So what we did, our color lab at Speed took 3 parts silica sand and blended that with our Portland Limestone Cement and the type 1-2 and made a mortar. And then they were able to shake the air out of those and took some pictures. And I guess the proof's in the picture because it's really hard for me to tell the difference between those 2 pucks. Very similar color. And again, what we have found is that, yeah, you can tell a difference in the powder, but when you put concrete sand with that color kind of washes out. And it's really not much of an issue going forward. So what about admixture efficiencies, things like slump retention? So we took the Mitchell cement and looked at that, looking at a different admixture dose. We did a untreated, we did 0%, I guess 0 ounce per hundredweight dose, 3 ounce, 5 ounce dose of a water reducer. And we did micro concrete, where we took the mini slump readings and carried that slump loss out for an hour, and then just looked at how much slump was lost. And so we found a couple of things. In every case, the PLC lost less slump, and in some cases generated more slump initially. So again, very positive return there on that test investment. Again, slump retention is again at least equal, if not improved. Something that we have already saw begin to pay some benefits on a couple of different projects. Okay, so let's talk about some data and some projects and kind of where we can take some of this data and make it come to life. So we have a customer in our North Central region that was interested in looking at the trial grind from our Mason City, Iowa plant, where we made a type 1L product late last summer. And so we just sent them the powder and they sent us some test results. Very, very nice of them to do that. And what they found again was things that we have seen in the Mitchell lab. So in terms of time of set, just a hair faster on the initial set, and just again about 16 minutes faster on the final set. So again, things that we've seen out of the Midwest, the Central Region cements, we're starting to see again out of those North Central Region cements. In terms of strengths, the same kind of properties continue to bear out, where we're seeing very equivalent like for like strength performance, well within standard deviation. And again, the report that we got back from our customer after they did their trial mixes, that they were very pleased that the results were so similar. So this is a good report where we didn't have our hands in this testing. This is a customer doing our testing, some evaluation for their own purposes. Have a customer in the Central region that is providing concrete for structural work. This concrete does have 510 pounds of our type 1L cement with 90 pounds of an F-ash. And so what you can see here is that the strength performance has been outstanding. 7 days, they've had some terrific values, 5,000 plus in almost every case. And again, the average for the 28-day data is 6710. The interesting part to me is that some of this has been at some cooler temps, anywhere from low 30s to mid 60s, without any adverse performance effects, and we're seeing the slump and things like that hold very steady. This is a trial mix that we did in our lab at the request of a customer, where we wanted to evaluate how would PLC perform in a precast mix. So we took this precast mix design and replicated that in our laboratory, and we used Mitchell type 1-2 in mix 1, and mix 2 was the EcoCemPLC. Pretty heavy cement doses at 675, again, a precast where they're interested in some early strength gain. One of the interesting points for me was that with the PLC, we saw about a 3.5 inch increase in spread, 3.5 inch increase in spread. To me, that kind of opens up some interesting options. And that does make sense, because if you think about SCC concrete, Typically, you add some kind of a fines to that mix design to help kind of hold everything together and carry the paste. And so essentially, that's what we've done with the addition of the limestone cement. So what this might allow them to do is save some money on water reducer. They might be able to cut back on their water reducer and still get, if 18 inches of spread worked for them, they've got some room there to knock that out, or they could pull water out and maybe cut back on the cement content. So those are some options we're going to help them look at as they move forward. But at the higher spread, they've got some fantastic results on strength, 5910 in 1 day, all the way up to 9620 in 28 days. So that's kind of an ongoing project where we're going to help them optimize their mix now with the inclusion of the EcoCemPLC. A couple of case studies to just take a look at, and we talked about this in December just very briefly, but I wanted to get into it a little deeper. And so at some point, if you have a question about this, we've got Scott Kelly on the call again, who was involved with this project. So at our Leeds, Alabama plant, it's a Lehigh cement plant, there was a silo constructed back in 2010, I believe. And this is a 3-chamber silo, about 20,000 metric ton capacity. This was a slip form project. And the good news here is that this was an opportunity to use PLC, not only just PLC, but it was a PLC slag combination for durability. And so here's how some of the data turned out. When we look at the C595 data, you saw that at different cement contents, that the 595 data exceeded the type 1 performance. And again, this was 420 pounds of type 1L with 280 pounds of grade 100 slag. And the 28-day compressive strength pretty much saw that same trend hold true with the PLC brakes above the type 1 brakes. And so some conclusions that were made after this project was over was that you saw the slag cement work very well with the type 1L Portland Limestone Cement. Current admixtures that were available for that project worked extremely well and predictably. It works well in complex concrete applications, produced a very low Coulomb durable concrete, and actually required less hydraulic pressure to continuously slip that silo. Something that's of interest as we talk about sustainability is that reduction in clinker factor. So on this particular project, there was a 52% reduction in clinker factor, which was a combination of using the type 1L cement and the slag cement actually allowed a clinker reduction. So this was a very environmentally sustainable mix that actually had outstanding performance in excess of what would have been achieved with just a type 1 cement. Talked about this again briefly in December, but it's worth mentioning again. We did an I-65 patching project where Lehigh worked with IMI on this project back in September. And so this was on Interstate 65 near Columbus, about 284 yards of patching and 68 yards of flowable fill. There was nothing unusual in this mix, pretty typical patching mix, had 752 pounds of Portland limestone cement. It was a higher performance flowable fill that was used. Some specs that were a little interesting was 625 PSI flex in 3 days for the patching, and the flowable fill had an 8-hour blow count of 30, and typically you might see that something as a 3-day count. So just to take a look at that, the flowable fill mix actually performed very well. One of the things that kept this project going in a real timely fashion was that IMI was allowing up to 8 hours for this material to set before they could start the patching. This flowable fill, which was a combination of PLC and FASH, actually reached blow count again in 2.5 hours and allowed that project to speed up a bit. And you can see in a couple of slides what that meant. In terms of concrete performance, the 3-day flexural spec was 625. The average 3-day break across this patching project was 730 PSI for that mix, and they actually were able to open the traffic in 12 to 15 hours. And so all those things combined, this project was expected to take 5 to 6 weekends, 5 to 6 Saturdays, because of the increase in the flowable fill set and just how well the PLC concrete gained strength. The project was completed in 3 Saturdays. I love that picture. That you get a good idea of just what kind of creaminess comes to the top there when that concrete's vibrated. And again, so some of the comments from that project: no change in admixture efficiencies with the PLC. That's huge. Again, they just pulled one powder out of a typical patching mix, put in the PLC, did have to make a very minor adjustment initially in air content. Once they got that in spec, they just ran with that dosage the entire project. Plastic properties of the concrete, very consistent, very stable. And again, just because of the performance, they were able to cut down on the length of the project. An older paving project that was out in Iowa. This was a project where we're looking at 2,536 yards of concrete that used a mix containing had 553 tons of type 1L cement in it. It was also had a 20% fly ash composition. 6-inch pavement. The interesting thing, and again, if you remember, we talked about slump retention and how PLC tends to extend that. There was a 19-mile haul from the concrete plant to the actual project site. And so here's a couple of pictures from that project at the Central Iowa Expo Center. And again, you can see now, once that's went through the paver, what we talked about in terms of just the finishability of the PLC because of those limestone fines, how the surface itself, but the edges just really stands well, holds its edge. Everything just looks fantastic. And again, very well received and a successful project from an Iowa paving job. So what if you want to specify PLC on a project? There's some tips for you available. What kind of specifications cover PLC? Well, just first off, understand that in terms of local DOTs, Illinois, Indiana, Iowa, Kentucky, Minnesota, Ohio, all allow use of type 1L cement on concrete projects. But ACI 318, 301, for instance, building codes for structural concrete specifications for structural concrete, all accept type 1L in those specifications. So this is, it's something that isn't new. Again, we have to remember this isn't a new product. It's something that's been in the marketplace for a while. It's just kind of making its way into our area. And so here's part of a sheet that the Portland Cement Association provides for you, a sheet on how to help you get PLC specified on a project. And these are their words. It says specifying PLC for use in concrete is not complicated. PLC is a direct replacement for ordinary Portland cement, so it only requires one change to project specifications, and that change would be refer to ASTM C595 type 1L instead of ASTM C150 type 1 Portland cement. And according to the PCA, their words, it's that simple. So some resources for you. The Portland Cement has made a fantastic website that I cannot recommend highly enough, called greenercement.com. And so on the left here is the homepage for that, reduce your carbon footprint with PLC. And I just want to point out the partners that are involved in this website: the American Concrete Paving Association, National Ready Mix Concrete Association, all these people that are involved in promoting what is a fantastic product that is really going to be able to allow you to make a difference in terms of your carbon reduction. So that website is www.greenercement.com. And so on that site, there's a couple of neat little calculators. On the site, there is a CO2 calculator. So it allows you to actually calculate how much CO2 can you save by using PLC on a project. And so they have an option to do that by volume. So I just put in 1,000 cubic yards. Say you did a 1,000-yard pour, and the cement factor was 564 pounds per yard. You were saving 23 tons of CO2 on that project by just using Portland limestone cement. And I would point out that there is also an option to select that for lane miles as well. So you can calculate the CO2 savings when it comes to paving. And again, that's one of the tabs on that website, greenercement.com. There's also links to several excellent PLC fact sheets, case studies, things like that. But for architects, engineers, specifiers, there's an awesome page called How to Specify PLC. So you can go to this site, explore that link, and it gives a lot of great information. Actually goes into a lot of detail on specification language, what that might look like for different projects and uses for the PLC product. Two papers that I just cannot highly recommend as well enough is state-of-the-art report on use of limestone in cements at levels up to 15%. I put the PCA R&D numbers on here so you can Google those. And then the second one's the durability of concrete produced with Portland Limestone Cement, 2 Canadian studies. If you can't find these online, give me a shout and I will email you copies of these. The one on the left, that was kind of my PLC Bible for about a year. It's about 78 pages. It's actually pretty readable. And it's just absolutely full of all kinds of information. And when you see PLC seminars, webinars, presentations where it's got all those graphs, that's where this is coming from. All that information can be found right in that state-of-the-art report on use of limestone and cements. So a fantastic resource, both those available for free. If you're a Tyler Lay fan, which probably most of us are, he's a fan of Indiana ACI as well. He has produced a short clip called PLC, A Greener Cement. And he made this sponsored by the Portland Cement Association as a way to help push the greenercement.com website. So would encourage you to check Tyler out. If you've ever heard him speak, you know he's one of the most engaging speakers in our industry. Just some other resources. In the July 2020 Engineering News magazine, there was an article called Reducing the Carbon Footprint of Cement in the Midwest. And also the CP Tech Center. If you're not receiving the CP Tech Center monthly newsletter, I would highly encourage you, go to CP Tech Center, .org, go to that website, and just sign up for that newsletter. It's fantastic. There's all kinds of great information, one of which is a Portland Limestone Cement after 10 years in the field review. And they just go back and look at a handful of paving projects, how those paving projects have stood up over 10 years. And it's information that I think would help us all feel better about, using a product that we may not know everything about quite yet, but really opens the door to us in terms of sustainability. So that's a great paper. Again, if you don't have that, let me know and I can email you that, but you can find it online as well. Okay, and kind of coming down the home stretch here, we have put together as a company a tech sheet for our EcoCemPLC product. This is available from your Lehigh sales group and your tech service group, so we can certainly get that in your hands if you have any other questions. And so what I wanted to do now is just share a customer testimony with you. This is a ready-mix producer in Philadelphia, and they made a video that is actually pretty fantastic about how they are making a difference with Portland Limestone Cement.
Caster Materials was started in 2004. We started as a very small with 1 plant, and we have now grown into 3 plants. We're extremely proud to be based here in Philadelphia. Everybody comes to work every morning. They put in 110%. They care about their job.
Our biggest thing is quality. It don't leave here unless it's right.
Want to make sure slump is good, strength is good, air is good. Sidewalk is totally different than foundation of the building, than columns of the building, the beams of the building, the slabs of the building. Totally different.
They care about what the next day brings, and they're forward-thinking people that want to help us grow. So our new product is EcoCemPLC. It's a environmentally friendly Type 1 cement. It's been a really good initiative that we're really proud to be behind this year. It's the right thing to do. I mean, the product is very much the same. If you can use the same product doing the same thing, but know that you're saving the environment, it's just a win-win.
This is a huge initiative for our company and for the industry itself. If we were to change or alter 5 million tons of Portland cement and produce Portland Limestone Cement, that would be in comparison to taking off over 100,000 cars off the road annually in the United States. It's a significant impact.
When you're delivering a concrete to professional cement finishers and mechanics, there's no margin for error.
Our clients, they actually see improved strength characteristics in the 24-hour short-term period. It's a lot easier to move, and it just makes the overall finishability and workability a slightly better product. If we can set the foundation from day one, we hope to be able to build buildings 100% environmentally friendly. And we're really happy to bring new products and new ideas to help fuel the never-ending growth here in Philadelphia.
Okay, pretty awesome story that Castor is a part of, and so they allowed us to use this material. I just love this as a closing statement. At Castor Materials, our mission is to expand and develop the ready-mix industry and take ourselves and our customers to the next level. EcoCemPLC Portland Limestone Cement reduces carbon emissions while requiring no change to current operational practices of concrete construction. Doing the right thing just got a whole lot easier. And so with that, I'm done with the slide part. I hope there's some questions that we can kick around and discuss. Larry, whenever you're ready for questions, let's get at it.
Mike, thank you. That was a great presentation. Again, great information that we were received. Anyone's got a question, please unmute yourself and ask.
Marty Sublett with Mac Industries. Has there been any rapid chloride permeability tests done with this?
Hey, Marty, this is Mike Collins. I know you know Jay Witt, so I think Jay's online as well. Jay, are you online?
Yes, the answer to that, it's in progress. We should have results here in within the next couple of weeks.
Okay.
Hey, Mike, and Marty, this is Scott down south, who Mike was referencing earlier. We have done some rapid chloride testing, and it's down with our version of the EcoCem out of our Leeds plant, and it is pretty much as advertised as the other attributes of EcoCem, as an equal to or better than. And what we have seen is as a slightly better than with the chloride testing.
Okay, thanks, Scott.
Anyone
Anybody
else?
Yeah, Mike, this is Mike Nelson for NDOT.
Hey, Mike.
Can you hear me? Yeah, just a general feel type question. It appears that this is certainly the way the world's going and the cement industry is going. Any idea, is type 1 going away? Do you anticipate 2-3 years, 1L is pretty much going to be it? Any thought on a timeline?
So yeah, here's what I would tell you. So my best guess on that is that I've told people within 10 years that their type 1L will be it. And I think there might still be a type 3 option or something like that. But type 1 will go away, in my opinion, within 10 years. Here's kind of what we're starting to see is that may be accelerated. A year ago, I was telling people 10 years. I'm not so sure. It may not be more like 5 or 6 at this point. But yes, I think you're right on in that the day will come when the type 1 or the type 1-2s will really just cease to be produced.
And second question, type 3, is there any talk of a type 3L, or does it not make sense for some reason to look at type 3?
I think it does make sense. It's not on our current radar right now as far as something we're going to do trial grinds on. One of the issues is type 3 is already a fine grind. So how much finer would you have to grind it? Because that does cost money to grind, right? I mean, it's a more capital intensive process when we have to grind those cements finer. So to me, that would be a question that would take some early investigation is, how much finer would you have to make it finer to keep equivalent performance? So yeah, I don't think it's not off the table by any stretch, but I think it's something that would be a down the ways for us a bit yet.
Next question.
Yeah, Bob Schaefer here with Ellis Brothers Concrete here in Ohio.
Yes, sir.
We use a product called Carbonite Microfines, which is a ground limestone fine. How does this compare with this, using this with PLC? You know anything about it?
Using it instead of PLC?
Well, incorporated with it, I guess.
Okay. Jay, are you familiar with that product?
Yeah. Yes. Good question. That is kind of concentrated in that region of northwest Ohio. It is a product that is added at the ready mix plant. We do not have any testing on that with our PLC, but in most knowing the dynamics of what the material is and how it's added, we wouldn't expect it to perform any differently. So your toughest struggle is how you're implementing it into your mixture, but we don't currently have any testing of our own done with this.
Okay.
Mike, I've got a question. When we start talking about loss of ignition and set times, what can we expect compared to the type 1s that we're currently using? I know some of the type 1s we use, they're dynamite, they really take off. Can we expect to see the same thing? Or are we going to see a little bit delayed action, or do we need to add a little more powder?
It's been our experience to this point, Larry, that time of set should be very equivalent. And honestly, there's been a couple of the trial grinds where we've seen even a little quicker set time with the limestone cement. So I wouldn't anticipate any retardation. And again, part of that's just a function of that being a bit finer. But in terms of overall set, to me, it's very, very equivalent.
Okay. I'll ask another one. So will it generate the same amount of heat in, let's say, a mass concrete pour or mass footings, where we go with a large amount of slag or fly ash to try and control the internal heat build? Would this be something that would work similar to that?
Jay, you want to chime in on that? Then I can too.
Sure. We've got some ADCAL results from various testings, starting cementitious quantities down to about 450 all the way up to 650. We are seeing a temporary spike, just slight increase in the initial stages between 0 and 12 hours, 14 hours. And then it's kind of meeting back together with a normal OPC mix, Portland Cement mix. So when you're considering mass mixes, my shift is always towards the design rather than of the total cementitious. So you deal with that first, and then you deal with what you're actually putting into it. So you're dealing with large quantities of cement replacement. And the testing we've seen with slag products and with fly ash products are we're getting about 10% increase with strength on our early stages between 14, 16 hours, all the way out to 24 hours. And you're about that same amount of heat generation, initial heat generation. So that's a long-winded answer to say that we've looked at this, but from a mass point of view, I think your mass calculations should be run equal, where the formulas could still be adequate, and you could still run the same testing. So we're not seeing any changes dealing with our mass calculations. We've got one project that's slated that we've done some testing here recently that we're actually planning on using the 1L with slag. Go ahead, Collins.
Yeah, I mean, you kind of brought that project in there that, you know, we're looking at a mixed design for a mass project now. And actually, you know, if you didn't know that it was PLC, you're not going to see any real significant difference. And again, there is that, and it's a good thing in most applications, there is that little bit of bump early with the PLC, but it's not significant enough that I don't think it's going to be an issue with the temperature control now. And you know, all SCMs that we've tried have worked well with the PLC. I will say slag, it seems to like slag especially. Just seems to be a real nice synergy there between the PLC and slag. So you know, that's something we're going to continue to look at. You know, SCMs, as everybody knows, is a bit of a roulette wheel right now. So you know, we want to try to stay out in front of that if we can, and continue to evaluate performance as different products become available.
Okay. So then leading into that, from that, so we've at E5, we've done some research with the limestone cement, with Jason Weiss doing the calcium hydroxide consumption and doing the calcium oxychloride test. Do you expect that this is producing more calcium hydroxide or less than a normal mix would? Not to put you on the spot. I'm curious as to what the results we're seeing is, what we can expect, going forward, because that's a big movement we've got in a lot of, DOTs around the nation. They're looking at consumption of calcium hydroxide, and, we're talking about trying to control it. Is this going to be more of a problem or less of a problem?
I can't anticipate that it would be drastically different. I hate to say too much about it because I honestly haven't dove. That's one area we haven't really got a lot into, so I don't want to misspeak on that. You've certainly given me that. That's a question that I'm certainly willing to look into more and try to get you a more definitive answer, because I think it is a good answer, or a good question. I don't think PLC will be a detriment in any facet of mitigating calcium oxychloride at all. I don't think that's going to be an issue, because it does, again, whatever properties that the type 1 or the type 1,2 from that plant have, that typically will be mirrored or replicated in the PLC. So I can't imagine that it's going to be any drastic difference, but I certainly would be up to looking into that deeper.
Thank you. Anyone else? Well, Mike, looks like we don't have any more questions. I want to thank you for a great presentation. I want to thank your technical guys for being on there, Jay Witt. Anyone else you've got on there, I appreciate their time being on here to answer questions and be part of this. We will be wrapping this up and getting it in a online video on YouTube here, hopefully this weekend, for people to review at their leisure. I will share, if Mike's okay with it, I'll share his information with you. Everybody can reach out and talk to him. He's a wealth of knowledge. So Mike, thank you very much.
My pleasure. I appreciate the opportunity.